Hi everyone, this video is about a solar powered lithium iron phosphate battery system that I designed and implemented to drive a laptop along with a weather station plus some other loads, including some radio receivers and so on. So this I wanted to be operational 24 hours a day, powered by this battery. And currently this is more or less a prototype system with slight undersized panels which I need to make a larger array so I can drive this and charge this, keep it charged basically off grid. Right now it's not able to drive and charge this up for the full load capacity for the day. So this is just an implementation to test the initial prototype. So what I have is a 60 volt DC solar panel system which drives a charge controller. This can handle up to 40 amp of charging current and can also drive a 20 amp 12 volt load, as well as of course directly drive the battery, which is in this case a 12 volt 230 amp hour lithium iron phosphate battery. It's got 4 cells, so it's a 4S system. The BMS that's controlling or interfacing with the battery is Jikong. I'll note the model number in the description below. It can also do 200 amps, which is plenty for the system. So the connectivity as far as the wiring for the BMS to the battery is shown here, with the B minus connected to the negative of the battery, the P minus going into the inverter load, which is a 120 volt AC 2 kilowatt inverter. And the P minus also goes to the battery terminal, and the battery terminal also, the positive goes to the the charge controller, to the charge controller, and also the B plus goes to the 120 volt inverter. So basically the BMS controls the operation of the controlling the battery for loads and for loading as well as for the charging part of it. And the balancing is done through these thinner wires, this is active balancing. It can do up to 2 amps of current into each of these cells, discharge or charge. So it's fairly powerful in that sense. It's got a much larger balancing current than most other BMSs out there. That's one reason I chose this. I don't need to have an extra active balancer outside the system. And basically the inverter then drives automatic switch which senses the battery voltage right across the battery. If it falls below 12 volts or so, this will switch to the mains and then drive the AC load. Once this voltage on the battery rises above 12.8 volts, it switches back to the battery and then disconnects from the AC mains, and then the inverter would then drive the load. That way I keep this system in a fairly good operating range without over discharging the battery, and also maintaining uninterruptible power supply to the AC load. In addition, I put in a 12 volt DC charger on the days when the solar panels cannot fully charge the battery. I basically drive the P minus and B plus through the BMS to charge the battery. So if the battery gets full, then of course the BMS will shut off the charging. So I don't want to directly drive the battery with the charger because it could overcharge the battery. So that way the BMS protects both the charging and the discharging aspects of this battery. There are also temperature control, temperature sensors from the BMS to the battery. There are 2 of them, and there's also a temperature sensor on this guy, which is probably not that useful, and it's also connected to the battery. So that's the entire system. There's also a Bluetooth connection to a BMS app, which I will demo in the subsequent video of this video, and basically highlight the system. In the future, I'll probably do a capacity test on this system to make sure it's meeting the 230 amp hour capacity. I'll do that using another measurement system which I use for typically battery testing. So here's the battery that I built. It's a 12 volt system, 4 3.2 volt cells in series to create the 12 volts. Each of these cells is 230 ampere hours, so it's a fairly powerful battery. You've got to be pretty careful. This is not fully built. I'm just testing it over here. Don't worry, I don't have children or cats in the house that can do something bad over here. Extremely high currents. If something falls on top of these, it's fairly safe right now. This is a auto switcher on the main supply. So the inverter is supplied through this output over here. The load goes out through this brown, and the utility is connected in here. So depending on the battery voltage, which is sensed by these two directly across the battery, this will automatically switch over to the AC power if this battery voltage goes too low, in case there's not enough power coming in through the solar charger, which is basically going into this charge controller. These two are from the solar panels, and this is the battery connection that's going to the BMS, these two cables. The BMS is what I really want to focus on in this video, is Jikong. You can see the connections have been made from these cables here, this thin red cables, and you'll have to look at the manual to see how that's done. It's a lot of videos on how this is done on YouTube. And basically one is the B minus, which is over here, the black one, and then each of them are sequentially connected to each cell, and there's a B plus that also connects to the positive of the battery. The negative of the battery goes to the negative B minus terminal of the BMS. There's a P minus, then goes to the load, and there's a B plus that also goes to the load. So total power is 230 ampere hours at 12 volts, which is almost 3 kilowatt hours in terms of energy storage, which is substantial. I'm driving a fairly small load of about 50 watts continuously 24 hours. In the winter time, I don't generate enough power to charge this, so I have a small charger, DC charger, which provides power to directly charge the battery through these two terminals. When the sun is up, it will basically also charge through the solar panels, and this charge controller will take care of that. As far as this is also a 2 kilowatt inverter, which is then used to basically drive the load. That is this laptop plus some other peripherals that are related to the weather station that I have over here. As far as the software is concerned, this is completely done through Bluetooth, and the initial setup really requires you to do a Bluetooth connection scanning, and then there's if you go through the manual, it's fairly trivial to set it up. There's a default password that's used to pair the device to the battery BMS, and once that is done, it will come up with the screen that is of course quite different from this. You got to first do some setup, which is to basically change the number of cells to 4 in this case, and then also the battery capacity in ampere hours, and you can also change the balance voltage. That is, whenever the cells are mismatched by greater than in this case 5 millivolts, it will start balancing. It's got active balancing, which is nice, up to 2 amps of current. And then you can also calibrate the voltage that is coming off the battery with what is being read on this system, on this page over here. This is the total current that is being supplied by the BMS. It can be either positive or negative depending on whether it's being supplying a load or it's charging. Right now it's getting 2 amps of charge going into the battery while it's also driving the load. If I turn on my DC power supply to compensate for some of this, to basically charge the system as well, I'm turning it on now, and you can see it's now gone up to 8.3 amps. So this is providing around 10 amps of current at 14.4 volts. And when this battery is fully charged, the BMS will basically shut off the charging part of it. So back to the settings. There are advanced settings also, where you can set up all your over voltage protection, under voltage protection, and certain delays and so on. a lot of parameters to adjust, including temperature related parameters. So this is something that you can set up. If you press the lithium iron phosphate, you'll get a default set of parameters that you can modify. And to modify, there's another password that's also given in the manual. So the default is 123456 for this one, and for the main pairing it's 1234. There's also a control where you can basically turn off the charge, discharge, and balancing. And so if each of these has a can be toggled right now. So if I turn this off, it will stop charging, and you can see that voltage has gone down. Current basically is not charging anymore. Back to the charge is on, so it's now charging at 1.2 amps. Part of the charge is also going from the battery into the load, so that's net charge entering the battery. Besides that, there's also heating. So right now I don't have a heating pad, but when I put it into an enclosure, I can put in a heating pad, and it will also allow you to basically heat the battery up from below when the temperature falls below a certain value. So that's nice to have if you're keeping this battery outside in the weather. I don't know what the emergency does, but the rest are fairly obvious, the first three at least. And so back to the main screen, it's got a lot of information. So right now the battery voltage is 13.14. The battery power is 23 watts based on these two, current and voltage. Capacity 230 ampere hours. So this is the amount of total discharge, which is 560 ampere hours. Average cell voltage, battery temperature T1 and T2. So there are two sensors that you can see are going, which are going below the battery. It's not visible here. The remaining battery capacity is 34%. Remaining capacity in ampere hours is 78. Number of cycles it has gone through, that is 2 so far. Cell voltage difference, so these are the individual cell voltages, which is all of them are 3.284 right now. Once they exceed 5 millivolts, the balance current will turn on. So I'm going to turn on this charger, and you'll see that it might actually do a balancing current because of the higher current going in. Now there's a 2 millivolt difference in the battery temperature, two of them, and then there's also a MOS, which is the internal MOSFET temperature, which is right now almost 22 volts. The heating is off because the temperature is quite high, and it's also saying it's charging and discharging. There's the balancing is actually now doing a discharge. You can see it toggles on and off. So very comprehensive setup or display, which is nice. And this can handle 200 amps right now of current, charging and discharging current continuously. So that's the basic description of the setup. Eventually I'll have to put this into enclosure with everything connected properly, heavier cables to minimize voltage drops. So that brings us to the end of this video. I'll try and do a capacity test and present that later to prove that we're getting the full 230 ampere hour from this battery. Thank you.